Hello, Precal. Hope everyone's having a fantastic day, fantastic week so far. Starting to get a little cooler outside. Just coming off a beautiful weekend. I hope you had an amazing time. Today we're going to be talking about transformations of trig functions. Now, the lesson before this was about graphing trig functions. And you know that once you graph something, usually after that you start transforming it. When you started graphing just straight lines back in Algebra 1, you started with a line, and then you said, okay, what if we increase the slope? Then what if we move it up? What if we move it down? Well, we're going to do the same thing with trig functions. We're going to start with our two basic trig functions, sine and cosine. Just practice with these for a little while. And we're just going to practice moving them, transforming them, moving them up, moving them down, increasing, decreasing. Now today is mainly going to focus around two things, and that's going to be what we call the period and the altitude. So for example, f of x is a sine bx, or f of x is a cosine bx. Now a here is the vertical stretch or shrink. Multiply the y values by a. This is how tall is it, right? We call the absolute value of a is called the amplitude. Amplitude. All right, so that's how tall it is. Now, this is how tall it is from the middle of a sine wave or cosine wave to the crest, or from the middle to the bottom of the trough, or to the maximums and to the minimums. This is the distance there between those. We call that the amplitude. It's how big a wave is. B is called the horizontal shrink or stretch. You're dividing by x values by B. The way that we set this up, it says since period of a function is normally 2 pi, the period of the transformation is going to be 2 pi divided by B, this B right here. So what I'm going to do is look at the value of B, and I'm going to say 2 pi divided by this number is going to give you your period. Now remember, the period is how often it repeats, right? So one full crest, one full trough, right? So B here is going to tell us how often that happens. We're going to do 2 pi divided by B. So let's jump straight into one of these here. Number 1, I'm going to keep this box kind of visible for you. Number 1, it says g of x is 3 sine of 2x. And the first thing they want is the period. We're going to graph the following functions on the interval of negative 2 pi to 2 pi. Alright, so first the period. Period, I'm using b, which in this case is 2x. So what I'm going to do is take my 2 pi and divide it by 2. Excuse me, it wasn't 2x, it was just 2. 2 pi divided by 2, and what does that give you? Well, that equals pi. So the period here is pi. Now, originally, the period for sine x was 2 pi, right? Cosine and sine, the original period, how long it takes for one original cycle is 2 pi. Well, what we're doing now is condensing that down to 1 pi. So we'll get to what that's going to look like here in a second. Back here on sine, the original function, 0 to 2 pi, right? 0 to 2 pi. And the way that we're going to set it up is the halfway point, right? Halfway between the beginning and the halfway point, halfway between the halfway point and the end. So we're busting up this thing into 4 equal parts. So we need to find where it starts, where it ends, the halfway point, and 1/4 and 3/4 of the way through. Well, this was easy. It was 0 and 2 pi, so halfway between 0 and 2 pi is pi. Halfway between 0 and pi is pi over 2. Halfway between pi and 2 pi is 3 pi over 2. Well, now we're starting at an origin of 0, 0, and we are going to end at pi. Or excuse me, let me do it this way so I can actually show you what we're doing here. And we're going to end at pi, right? Well, what's halfway between 0 and pi? What I'm doing here is building my x values. What's halfway between 0 and pi? Well, that'd be pi over 2, wouldn't it? If we keep going this way, what is halfway between 0 and pi over 2? Well, that'd be pi over 4. Halfway between pi over 2 and pi, well, that'd be 3/4, 3 pi over 4. Once you have your period set up, we're going to go through and we're going to plug these x values into our function and come up with the y's. Now, something that'll tell us a little bit about that here is the amplitude. Remember, amplitude is how tall it is, and in this case, a here is 3. It's 3 times as big as a regular sine function. So my amplitude is 3. Okay? If I plug a 0 in here, 2 times 0 is 0. The sine of 0 is 0 times 3 is 0. All right? Say I plug pi over 4 in here. Ooh, pi over 4. So 2 times pi over 4 is 2 pi over 4, or just pi over 2. The sine of pi over 2 is 1 times 3 is 3. What if you plug a pi over 2 in here? Well, 2 times pi over 2 is pi. The sine of pi is 0 times 3 is 0. 3 pi over 4, right? This ends up being 6 pi over 4, which is 3 pi over 2, right? So this is the sine of 3 pi over 2, which is at down by the 270-degree mark. The sine of 3 pi over 2 is negative 1, excuse me, times 3 is negative 3. Now we've got pi times 2, 2 pi. Sine of 2 pi is 0, times 3 is 0. Let's go through and graph some of these points, see what they're going to look like. My original is 0, 0, and then I'm at pi over 4, comma 3. Now pi over 4, since this is broken up into segments here of 3's, like this is broken up into pi over 3's, it's going to be in the middle here. Here's pi over 2, so it's halfway. Pi over 4, comma 3, right? Pi over 2, comma 0. 3 pi over 4, comma negative 3, and pi, comma 0. There is 1 period. Now, what's cool about this is after that, we can just repeat it, right? So the next point will be here, then here, then here, then here. We can go the other direction and repeat it there as well. We got here. And as long as this thing is symmetrical, as long as it is symmetrical, you know you're doing it right. So you should be able to clearly see that what you're doing is making a sine wave. You should be able to clearly notice that what you're going to produce will be the sine wave. It's a lot easier to do it like this. It usually comes out looking a lot nicer if you do it vertically. So here we have a sine wave with an amplitude. This is your amplitude right here of 3. Notice you could go here or here. Your amplitude is 3. Domain here is going to be all real numbers. Range is going to be, now on this window, remember on this window, this is the function we're talking about now. Range goes from negative 3 to positive 3. Okay? So the hardest part about this, honestly, is going to be splitting up your periods because it's a lot of fraction work. All right, let's go to the next page. That's all the lesson is, really. And it's just more practice from here. Okay, so I'm going to try and get through this one a little bit quicker here. Your period is 2 pi over b. B in this case is 3, so it's 2 pi over 3. Amplitude here is 2. Now, I don't care that it's a negative. When I get my points, the negative will take care of itself. I want you to note here, this is always positive. Back from the front, it said that the amplitude was the absolute value of A, so it's always going to be positive. So I want you to write a note here, little asterisk. Write a little note to yourself here. Let me flatten this out. Always positive. Okay, so let's set this up. Here's the original cosine function. This is just so it'll be a little bit easier for us. This is the original. My original period here was 0 to 2 pi, and now my period is 0 to 2 pi over 3. All right, so notice it goes from the origin to the end of the period. The end of my period is 2 pi over 3. Now this is where this gets a little interesting. What's halfway between 2 pi over 3 and 0? Well, if you have 2 of something, cut it in half. That'd be 1/3, wouldn't it? Halfway between 2 pi over 3 and 0 is pi over 3. What's halfway between pi over 3 and 0? If you had 1/3 and you cut it in half, what would you get? You'd get pi over 6. Same way here. If we took and we added to this, or if we went halfway in between pi over 3 and 2 pi over 3, a little fraction work here. But if you go halfway in between that, you're looking at tacking onto this a pi over 6. You've already got 2 pi over 6 here, so that would be 3 pi over 6, which is pi over 2. Let's go through and find out what these values are going to be. First, the cosine of 0, or the cosine of 3 times 0. So 3 times 0 is 0. The cosine of 0, this is where you got to be careful. Cosine of 0 from your unit circle is 1. So negative 2 times 1 is negative 2. Pi over 6 times 3 will be pi over 2. It'll be 3 over 6, which is pi over 2. The cosine of pi over 2 is 0 times negative 2 is 0. Pi over 3 times 3 is just pi. Cosine of pi is negative 1 times negative 2 is 2. You got pi over 2 here. 3 times pi over 2 is 3 pi over 2, which is down at, remember it's down at your 270 degree mark, 3 pi over 2. Cosine of 3 pi over 2 is 0 times negative 2 is still 0. 2 pi over 3 times 3 will be 2 pi, because your 3's will cancel, 2 pi. Cosine of 2 pi is 1 times negative 2 is negative 2. Let's plot these points. Starting at 0, negative 2. Pi over 6, which is here, comma 0. Pi over 3, comma 2. Pi over 3 is here, 2. Pi over 2, comma 0. And 2 pi over 3, which is here. Wait, did I get... Yes. Right here. Notice how these pi's are busted up into 6 pieces. So here's 1 6, 2 6, 3 6, 4 6, which is 2/3. And remember how I told you one period can go from crest to crest, trough to trough, as long as it includes one full crest and one full trough? Okay, here's your trough. That's half of a trough. Here's your full crest. Here's your other half of your trough. That is one period. And from there, you can just repeat. Now, here's how I like to do this. Find out how far it is from your zeros. So, so it's here, skip to here, skip to here, skip to here, Here.